Hello everyone. This is lesson 3.1 or the Newton's first law of motion. While students are entering the classroom, show this slide on screen. The teacher is advised to meet the students at the door and hand in to each student a copy of the bell ringer. When the bell rings, click this slide, which reminds students that they have 5 minutes to complete the bell ringer. While students are doing the bell ringer, the teacher will check their attendance, then distribute the classwork sheets. At the end of the 5-minute period, discuss with students' participation the bell ringer. Lesson 3.1, Newton's first law of motion. By the end of the period, with at least 80% mastery, students will be able to define force, balanced and unbalanced forces, state and explain Newton's first law of motion, and use Newton's first law to explain everyday life phenomena. What is a force? A force is a push or pull that one object exerts on another object. Balanced forces versus unbalanced forces. Balanced forces are equal in size or magnitude, and they are opposite in direction. Balanced forces do not cause a change in motion. Unbalanced forces are not equal in size and or direction. Unbalanced forces cause a change in motion. And balanced force is called a net force. Example of balanced forces. In this picture, a truck is at rest. There are two opposing forces of 100 newtons each. These equal forces are acting in opposite directions, therefore no motion is produced. In this picture, the truck is initially at rest. There are two unequal opposing forces that act on the truck. One is 100 newtons to the right, and the other one is 60 newtons to the left. Since the two forces are unequal, the truck will then move in the direction of the 100 newton force, which is going to the right. There are three laws of motion. The first law of motion is called the law of inertia. The second law is called the law of acceleration. And the third law is the law of action and reaction. Newton's first law, or the law of inertia, it says an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. In this picture, these pumpkins will not move unless acted upon by an unbalanced force. Unless acted upon by an unbalanced force, this golf ball would sit on the tee forever. But once airborne, unless acted on by an unbalanced force, that is gravity and air, which is also called the fluid friction, it would never stop. Why then do we observe everyday objects in motion slowing down and becoming motionless, seemingly without an outside force? It's a force we sometimes cannot see, which is the force of friction. What is the role of friction? Friction is an unbalanced force that opposes or slows down the motion of an object. There are four types of friction: the sliding friction, the rolling friction, fluid friction, and the static friction. Slide a book across a table and watch it slide to a rest position. The book comes to a rest because of the presence of a force, that force being the force of friction, which brings the book to a rest position. In the absence of a force of friction, the book would continue in motion with the same speed and direction forever, or at least to the end of the tabletop. Inertia is the tendency of an object to resist any change in its motion. Inertia means that the object's motion will stay constant in terms of speed and acceleration. Inertia depends on the mass of an object. Objects with a greater mass have greater inertia. Mass, not weight, is a measure of the amount of material in an object. It is a quantitative measure of inertia. It is more difficult to change the motion of a bowling ball than the motion of a golf ball because the mass of a bowling ball is greater than the mass of a golf ball. Inertia does not depend on the presence of gravity. An object's inertia is the same on Earth and in space. Which vehicle has more inertia, the hammer or the automobile? This picture shows that the larger the mass of an object, the greater is its inertia. Look at this animation. The truck is in motion. What is the force that causes it to stop? The pose of the stopped car. The car is at rest. What is the force that causes it to move? The pose of the truck. The law of inertia is most commonly experienced when riding in cars and trucks. The tendency of moving objects to continue in motion is a common cause of a variety of transportation injuries of both small and large magnitudes. Consider, for instance, the unfortunate collision of a car with a wall. Upon contact with the wall, an unbalanced force acts upon the car to abruptly decelerate it to rest. If the car were to abruptly stop and the seat belts were not being worn, then the passengers in motion would continue in motion. Now perhaps you will be convinced of the need to wear your seatbelt. Remember, it's the law of inertia. If the motorcycle were to abruptly stop, then the rider in motion would continue in motion. The rider would likely be propelled from the motorcycle and be hurled into the air. Once they leave the motorcycle, the rider becomes a projectile and continues in a projectile-like motion. Consider, for instance, a ladder strapped to the top of a painting truck. As the truck moves down the road, the ladder moves with it. Being strapped tightly to the truck, the ladder shares the same state of motion as the truck. As the truck accelerates, the ladder accelerates with it. As the truck decelerates, the ladder decelerates with it. And as the truck maintains a constant speed, the ladder maintains a constant speed as well. But what would happen if the ladder was negligently strapped to the truck in such a way that it was free to slide along the top of the truck? Or what would happen if the straps deteriorated over time and ultimately broke, thus allowing the ladder to slide along the top of the truck? Supposing either one of these scenarios were to occur, the ladder may no longer share the same state of motion as the truck. If there are no more questions, Then let the students complete the classwork until the end of the period.